lesson 4 because most probably next week I will go back to lesson 4, but today I will do lesson 5, which is servo motors. Okay, today's lesson I won't be dealing with any more LED, no more buzzer, no more switch. We are going to touch something entirely new. Okay, who in this class does not know what's a servo motor? Does not know what's a servo motor? Raise your hands. Okay, I will start this lesson with a video then. Okay? Are you ready?
Hello and welcome to Maker Hanger. My name is Lucas Wigley and today we're going to be talking about servos. We'll take a look at how they work, how they're classified, and how to hook them up to the control surfaces on your plane. So let's get started. So servos are made up of small brush motors, a potentiometer, and a couple of gears. The potentiometer regulates the movement of the motor and allows the servo to move exact amount of degrees. A servo can move 180 degrees mechanically, but under its own power it can only move 90 degrees. If you take out the pot and replace it with a fixed resistor, then you have a continuously rotating servo. There are two main types of servos, analog and digital. They're both the same with all the physical parts, the potentiometer, the gearing, and the brush motor, except for the digital servos have a microprocessor that takes in the input from the receiver. This allows them to be more accurate and faster. Because of this, they do take up more power, however, it's not going to be very significant in the plane. The next set of classifications is if a servo is either metal or nylon gear. Yep, you guessed it, this just means the gears inside of the motor are either metal or nylon. And obviously metal gear servos are much stronger and they don't strip as easily. The next classification is weight, and 9-gram servos are the most common because they're used in foam airplanes. There are also several other types of servos that are categorized by weight and size. 9 grams are considered micro servos. There are also sub-micro and standard size servos. There are a couple other types, but you'll probably only deal with micro servos when building foam planes. Then, voltage is a factor. Most servos run off of 3 to 5 volts, but some high voltage servos run off of 7.4 or a 2S LiPo pack, and these are for larger planes that require more torque. And the last classification is torque. You shouldn't really have to worry about this because when building a foam airplane, any small servo will be able to push and pull the control surface. And metal geared servos will be good for almost any application. Now let's talk about linkages, and there's a couple parts you're going to need.
Okay, I'll stop here. Okay, back to servo motors. Okay, do you have a better idea of what a servo motor is?
No.
Okay, a servo motor is not the same as your normal motor that runs in your wheels of your oil car. Okay. Or those motors that run the fans. It is a special kind of motor where you can control the angle of how much it turns. Okay? Now, a servo motor can only turn between 0 to 180 degrees. If you pay attention to the video, it can only turn between 0 to 180 degrees. So you cannot turn your servo to 360 degrees because inside there are some gears which limit the rotation. Okay? Later I'm going to pass you a servo motor each. When I pass you a servo motor, I will do not turn the linkage forcefully. Okay? Because when you turn it, I can hear the sound. Let your Arduino control the servo. Okay? Now, where can you find servos? At the end of the clip, if you remember, you see this toy airplane. So imagine you have a wing, and then at the back of the wing of your airplane there is a flap, and then I connect my servo here. So if I pull this servo, my flap will move together with the servo, right? So this will help the plane to go up, to go down, or if you push it down, you go up. That is how your airplanes, your real airplanes, fly up and down. It shifts the flap of the wing at the behind of the wing. Okay? Now, robotic gripper. Robotic gripper is something that you will be building next time when you come back after your exams. So you'll be using a lot of servo motor, you're using 4 servos, or is it 2, to create a robotic arm. So that's why I push this lesson forward so that everybody can have a hands-on of this. Okay, how about okay, have you went for your learning journey?
Yes.
To Nanyang Poly?
Yes.
Okay, if you go for the learning journey, you do or you meddle around with some assistive technologies, right? You play around with the wheelchair, you play around with luggage, the seat, remember? Alright? Okay, I'm not sure whether you have said this is called a prosthetic arm. So for example, if I lost a limb, and then I want to have a mechanical limb, which is called prosthetic arm, the joints of the limb, it could also be a servo motor. Okay, or we will just big joints. Alright, Iron Man. Who in this class does not know what Iron Man is? A lot of you do, right? Okay, Iron Man, you have all those movable parts really assembled to become an armor. All these movable parts could also contain servo motor. Why? Because a servo controls the angle of the movement. You will see later how a servo changes, controls the angle.
Sure, but then Iron Man can swing 360 ways.
He is a lot.
Iron Man turn.
Yeah.
Okay, the mask, when you open the mask, it opens this way, right? Correct? Is it 360? So for example, this is the mask, this is where the point is, so it shifts. Okay, for example, this is the mask, then you open like that. Correct? So this is his joint. Okay, the joint is my face here, okay? So this is the mask, this is the metal plate, and then it shifts down. Is it 180 degrees? Within 180 degrees? So that's what a servo could possibly do. Okay, moving on. Can everybody turn to page 2 of your worksheet? Okay, page 2 of your worksheet, I have 3 choices for you: DC motor, servo motor, and a stepper motor. I have given you an image. I want you to circle which of these 3 represent the image. Now, a DC motor, where you can find a DC motor? A DC motor you can find in, toy cars. You play Tamiya cars, toy cars. Okay, those kind of cars have DC motors in their wheels. If you want to see how a DC motor looks like, let me just show you how one DC motor looks. Okay, this is a DC motor. Not sure. I will let you guys pass this around. A DC motor is much bigger than your servo. Okay? I will pass this around and I want it back with the wires intact. In the meantime, I will pass you your servos for you to touch but not turn. Okay, next, the library that we'll be using today. Okay, this is the command that we'll be using to control your servo. Like your LED, I will use the digital right. Correct? If I want to make my LED light up, I will use this command called digital right. And then if I want to make my buzzer sound, I will use this command called tone. That is what you study for lesson 2. So to use your servo, I will use this thing, a library, to control it. Okay? I want you to pay attention later because you have to type the program. You must take note of these square brackets. Sorry, not square brackets, angle brackets. Okay, when you type, make sure you type things properly. Okay, today we will not have many components. This is one of the easiest circuit to set up. This is what you will need: a servo motor and jumper wire. I will not give you a capacitor. Okay, capacitor is not given to you, so you won't be using a capacitor. Okay, if you have been touching your aluminum board for a long time, for a while, you will realize on the digital pin, everybody look to the board. Everybody look to the board. Don't start connecting yet. that on the pin of your digital pins, you have these lines there, correct?
Yes.
There are 6 of them, correct? They are squiggly lines. Now these are special pins and they have names. The pins are 3, 5, 6, 9, 10 and 11. Okay, if you look at the bottom of your worksheet, I have given you a table. What I want you to do is to put a tick on all the 6 pins which have the squiggly lines. We are going to put a tick on all the pins which have the squiggly lines, which are 3, 5, 6, 9, 10 and 11. This pin has a name. The name is called PWM. And only 6 pins can control the servo. Any other pins cannot control the servo. Clear? Yes? Okay, today we will be using pin number 6. So bear that in mind.
I'm my YouTube channel.
Done?
It's about learning games.
Done? Okay. This is the connection that you'll be connecting. I just want to highlight to you that when you get your servo, you will have 3 wires. They are brown, red, and orange.
Because